Today is going to be part 2, algebra, and introduction to it. Specifically, we're going to focus on why do we need it and how it works. I believe this is probably one of the 2 most important videos. The first one being the assessment, where we talked about the most common issue people have. And this will be the second most common. And I don't just mean all of algebra, specifically number 3. So for those of you that think I already know this stuff, stay tuned and make sure you know number 3. All right, so what is it and why are we using it? By the way, this is the origin from the Arabic word, and it means restoration. Okay, so 2x equals 8. I mention this because math comes from a collection of ideas from different places. It's not just one civilization that came up with everything. All right, so the x here is a mystery value. So this is not a multiplication symbol. We could use a Q, we could use any letter. So in algebra, we'll typically use letters of the alphabet. You can use Greek letters. Anything is fair game, you just don't want to use numbers. Okay, so let's say this is a Q. So when we write it right next to each other, this literally means 2 times Q, but we're going to be doing this so much that we oftentimes just drop the multiplication and write it right next to each other. So if we're saying 2 times something equals 8, a lot of kids, this is how a lot of algebra is taught. And so what I would do if I didn't know algebra, just say, hey, I could see 4 works. If you plug in 4, 2 times 4 is 8. And hence our first method, which is guessing. So you didn't use anything fancy. Let's see, we can even make this a little more involved. So let's say 2x, could be lowercase, uppercase, doesn't matter. X, Y, Z are typically used. So you'll see me using that a lot. So let's say 2x plus 4 is 12. Another standard beginner problem. And a lot of teachers will say, well, you know, my kids are having trouble learning algebra. Well, the problem is this is a very easy problem, so there's no motivation to learn anything. You could just guess a number here that makes this 12. So let's say you try 5. 2 times 5 is 10. That's, remember, not a multiplication, but a mystery value. 2 times 5 is 10 plus 4 is 14. Too high. Let's try 4. 2 times 4 is 8 plus 4, 12. Great. So x is equal to 4. Now, we didn't have to do anything fancy at all, so we haven't actually even done algebra yet. We've just guessed a value that works. I mean, we're working with algebra, but we're not using any algebraic techniques. All right. So the point I'm trying to make is I've seen countless students have trouble getting good at algebra because most of the problems in school that you're going to see are pretty simple. So if I can guess an answer, why do I have to learn something new? And I can guess this pretty quickly. I tried 5, didn't work. My second guess worked. Super fast. All right. Why do we need it? Well, if the problem gets weirder like this, so now we're saying 5 times some value minus 18 has to equal 76.3 plus 237 times that same value. So these can't be different numbers. This has to be the same number. Now you could try, let's try 70. So you plug in 350 minus 18. This time 70 is going to be way too high, so that's not going to work. All right. The point I'm making is students will very quickly give up on this problem because this guessing method no longer works. It's not a bad method, but it's not a very powerful method. All right. So this is the sort of problem that might motivate a student to say, hey, I need a better tool to solve this problem. All right. So let's go back to a basic problem just so the numbers are easier, but what we're going to discuss here will work on this problem. So let's go back to a simple problem like this. Let's make this 60. Okay. So we're going to discuss 2 methods, balancing and moving. In my experience, most students are only familiar or mostly familiar with balancing. This is what's taught in schools. This is very good. There's nothing wrong with this. The problem is that a lot of students are unfamiliar with this other way of thinking about things. So I don't want to say anything bad about this, but if you only have this, you only have half the puzzle. All right, so what is balancing? The equal sign means this is like a scale, right? So if I have a 500-pound horse here, I need a 500-pound horse here. If I have this one at 499 pounds, they're not going to balance. So by balancing, we're going to use this concept of restoration, which is we're going to try to undo stuff that's going on to get an X. So in other words, this looks like something's going on. If this plus 4 weren't here, this would look simpler. So that's what we're going to try to do. We're going to try to work backwards. The stuff that's plus and minus is sort of more loosely attached, so we're just like order of operations. So we're going to try to do that first. The multiplication, division stuff, the stuff right with the variable, is going to come later. So what the balancing method says, well, this is currently balanced because there's an equal sign. So if we want to keep it balanced, we can't just subtract 4 from the left side. So we're going to subtract 4 from both sides. Now, why do we pick subtracting 4? Because I want to undo this to simplify it. So 2x is 12. That's gone, and that's 12. All right, so now we say, what do we want to undo here? We want to get rid of this 2 because we just want to know what x is. We don't want to know what 2x is. So we're going to undo multiplication. So that's the division by 2, divide by 2, and we get x equals 6. All right, that is in a nutshell the balancing method. So what we're doing is we are trying to get rid of everything that's next to the x, and whatever we're doing to both sides. Boom, boom. All right, let's see this in action on a slightly more involved problem. So let's say 5x plus 2 is 12x minus 4. All right, so here we have x's left and right. So first order of business, let's group all of our x's. So I like to put the x's towards the side that already has more of them, so we can avoid negative numbers. So let's take this and put that there. So we're going to say minus 5x minus 5x. All right, we're going to do one step at a time. So now we're going to have 2 is equal to 7x minus 4. That stayed a 2. This is gone. That's a 7x. That stays. All right, this is looking a little nicer than this first line. So now we say, hey, the x's are here, so we want the numbers over there. So 6 is equal to 7x. Notice we're doing the same thing to both sides. So now we have a 7. We want to undo the 7. Divide by 7. Divide by 7. So we get x is 6 over 7. All right, so when you have more than just x on one side, the balancing method works. In fact, this pretty much is always going to work. This is actually very great for really large problems. So if I have a ton of things going on, like 2x minus 5y, some other variable, plus 37 plus x squared, which is x times x, the mystery value times itself, is equal to 7x plus 2y minus 12. There's a lot of terms. So we might not be able to solve because there's too many unknown things. We don't know y, we don't know x, but we could simplify this. We could collect the x's, we could collect the y's, and we could collect these numbers. So in the balancing method, I think of this as accounting. So whatever you do both sides. So you say minus 2x, minus 2x. Let's put the y somewhere, so this is plus 5y. You just always undo the operation. So pick the opposite. If that's a minus, that's a plus. Minus 37, minus 37. So at this point, these are gone. And here we get x squared, that stays. Negative 49. Okay, so this was pretty good. The point I'm trying to make is, if you guys are feeling like, hey, this is algebra kind of sucks, this is boring and tedious, you're absolutely right. This method, I don't like this method at all. However, for large problems, I do like using it so you're organized, you don't make a mistake. Most of the problems you'll encounter in your life, in school, all these toy problems, will be either short problems or medium problems. They're not often going to be this long. So in those cases, I highly, highly recommend using this method. So let's see what the moving method is. So let's go back to this problem. 2x plus 4 equals 16. All right, so the balancing method says whatever we do to both sides of the scale. So minus 4, minus 4. Now let's think about this. Why do we write 2 minus 4s? We already know the point of this is to eliminate that. So why write it? Every time this is just going to give us nothing interesting. So what the moving method does, it says, let's not write 2 negative 4s. Let's just focus on one thing instead of 2. In other words, don't focus on these 2 negative 4s. You're going to take this. We don't want this here. We're going to move it. That's why it's called moving. Balancing, you do things to both sides. Moving, you're literally doing half the work. So 2x, and now this is the key thing. So to use the moving method, there's two main rules for algebra. Plus goes to minus and vice versa, and times goes to division. So if you like the moving method, which I recommend that you use, these are pretty much the two rules that are going to get you through 95% of algebra problems. Plus goes to minus, minus goes to plus. Times goes to division, division goes to times. So what do I mean? This is a plus 4. So when you change sides on the equal sign, that's what these arrows mean. It turns into a minus 4. So the benefit of this is we don't even have to write anything. So if you see this, in your head you can see the 4 is going to go here and turn into a negative 4. So 2x is going to be 16 minus 4, or 12. Right, I'll just write it so we can follow along. Now, this is a multiplication, 2 times x. We want to undo the 2, so how do you get rid of a multiplication? We're going to just move the 2. So when you move it, it doesn't stay multiplication, it turns to division. So now this 2 goes here, and it's no longer here. So x is 6. Now let's go to the original problem. So the reason I like this is you could do this whole problem, the moving method, you could do the whole problem in your head. You say 2x is 12, the 4 went there. X is 12 over 2, x is 6, without doing any work. So we could do this completely in our heads very easily just by using the moving method on this problem. So let's see, again, why this is so awesome. So let's say we have 3 apples is to, 3 people can build 5 bricks. So I'll say 3, I'm going to set up a proportion. 3 people is to 5 bricks, whatever that means, as 7 people is to how many bricks? Okay, so first of all, we set it up properly. We're making sure that we could have set it up people is to people as bricks is to bricks, but the point is one unit corresponds to another unit. So people bricks, they align. So the units are correct. So the question is 3 over 5 equals 7 over what number? So you can ignore the units, but this would be a standard problem you might see. So we're just gonna solve this. All right, so using the balancing method, you would say, oh, here I want to find this, so let's multiply both by x. So for every step, you're going to end up doing a ton of work. You're literally doing twice the work. Yep. It's going to be very unintuitive. So you're going to spend like so much work, it's going to be very slow. You're not going to see the solution in your head. If you're doing the moving method, you could do this problem in 5 seconds in your head. So let's see how we would do that. So x is on the bottom, so it's 7 is divided by x. We don't want it to be dividing by x, we just want x on the top. We just want x equals. So we could also actually flip both of them. It's going to be the same thing, but I won't get into that just now. But if you guys have questions, we can get into that. So you could just flip all of them, that's legal. But let's just focus on these two. So x is on the bottom, so it's division. We're going to turn division to multiplication by crossing the equal sign. So the x is going to go up here, from down to top. Now the x is going to be with these numbers. We don't want these numbers with the x, so now we're going to get rid of them. This goes here, 3 goes here. So in our heads, we're just going to say x goes here, x equals, 7 stays, 5 goes there, times, and the 3 goes down, division. So division turn into multiplication. The 3 with the x is multiplication, so the 3 is now dividing. So basically, you just flip operations when you cross the equal sign. So this is the power. We can do this problem completely in our heads with no work. Like I said, if there's a lot of stuff to do, you might want to use this. I don't want to trash this completely, but most problems you'll see will be sort of like this, where you can get this and people are going to stare at you like you're an alien. How did you get this? All right. So let's do this with a little scarier problem. So now we just have no numbers, so 4 mystery values. So some number over some number has to be some other number over some other number. and we want to know what is D in terms of the other letters. So for example, if this is 2/3 equals 4/6, then you could say we can move the 6. We're going to be doing the moving method. So you can just plug in numbers if you're having trouble with the letters. So D goes here, B goes there, A goes there. So it's going to be CB or BC. The order doesn't matter for multiplication over A. That's it. That's all you have to do. Now if we had started with D over C, D's already on top, so we just have to move the C. So D would be equal to AC over B. And I prefer to write it the other way to the right, so we could express it as D is something, not something is D. And that's pretty much all there is to it. So again, this may seem like a minor thing. This is super critical. The moving method is awesome. You guys should be really looking into this. Let's do one last practice problem and then we'll wrap up this video. So let's say you have all these letters. All right, now so each of these letters represents some number. So this is A times B times C over D times E times F. It's a mess, right? And so let's say the question is, what is B, K over D, E, G in terms of the other letters? So this is looks like a complete nightmare. Now, you may be thinking, like, why am I going to need this? For now, if you could just follow how we're using these two rules, you're going to be in good shape for the next few videos. So here's the idea. We look, hey, B's staying put. It's on the top. It's on the top. Don't touch B. For K to come here, that means K went here. Okay, that's reasonable. The D stayed put, and the G went down. So basically, we have to see what happened to this A. Well, it must move down because multiplication turns to division. So the A is down here. All right, what else is? So we're just like matching puzzle pieces here. The F. The F is not here, so the F has to go there. All right. We have the G. We have no H, so the H and I stay put, just like they were here. Let's see. You got to orient yourself a little bit. So there's no JKL, so the K is here, but the J stays, and the L stays. So why do we not put the K? Because the K went from here to the top. So hopefully you could follow this example. The point I'm making is if you're using the balancing method, each one of the things we just did would have taken you like half a page of work. So the whole problem would have taken you half a page of work. And moreover, if you're just trying to do some sort of multiple choice thing and this is a choice, there's no way in the world you're going to be able to intuitively see this as a choice if you're not thinking about it in terms of moving one object. If you're thinking about it in terms of accounting, it's not a creative method. It's just a careful method. So let's wrap up. So you have these three methods. This is a very primitive method. So when people think algebra, they usually think these methods, primarily balancing. But I encourage you guys to use moving. And guessing is not terrible. There's going to be a place for it, so keep that in your back pocket. That we're not going to throw it out forever. It can help us check things. So for example, if we have 2x equals 8, and for some reason you got x equals -4, well, you can plug this into C, doesn't work. But also just this primitive method is sort of like the common sense method. This tells you, wait, this doesn't make sense. A positive times a negative is not going to give me 8, so this will be handy. All right, I'll see you guys in the next video.